Okay, allow me to record this meeting. Okay. Oh, now it's azan, so I think we quite silent for 1 minute. Okay, I think we can start. Maybe participant can mute the. Please mute. Please make sure all the participant mute the microphone. Okay, let's start our lecture tonight. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah.
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, very good morning, very early morning to our guest lecture, our Mr. Ramesh Rao. I believe now is a very early morning in San Diego. Now is 5 o'clock in San Diego. Thank you so much for accepting our invitation to give a lecture to our students and our public in University of Indonesia, and all also not only student in UI but also students from other university and all the participants in Indonesia. And welcome all to our audience. Most of our audience is graduate student in University of Indonesia. We have around 80 to 100, 80 to I believe 80 graduate student for the commencing year for this year 2021. Yeah, for the first year of master degree is 80 students, and we have the active student also who are now in the second year of their magister program, and we have the undergraduate student here, and we have also our colleague from University UGM. Yeah, also we also invite ITS and other university, and here in participant also from Padang, from Singapore, and some of them are, I think I look at on the registered, and the registered form is Cimahi and others. So I hope all of you are in a very good healthy condition at the moment, because tonight we are going to have we expecting to have a fruitful discussion after following the lecture by Mr. Ramesh Rao about the technological trend in the next decade. Mr. Ramesh Rao, as you can see on the flyer, he has a very long time experience in industry. Now he is the Senior Director of Engineering Qualcomm, Technology Licensing, and he is living in San Diego. Now he's live from San Diego. And tonight he's going to give us the lecture for around 45 minutes, followed by the discussion. So we expect all of us will join the fruitful discussion and elaboration about the topic, because we're going to shape our mind and reach our understanding about what will be the future. And after that, after knowing the trend of the future, we as an engineer should answer the question. So then, after we know the future, what competencies should we as an engineer have to survive in the industry? Or if you see on the flyer, to be champion in industry. So that's the concept of our tonight lecture. This lecture is held by the Magister Program, Department of Electrical Engineering, University of Indonesia. In Indonesian word, we call program S2. And electrical engineering have the specialization. Electrical engineering is the main umbrella of this Magister Program. And the specialization is, you can see here, automation and rekayasa analysis data, telecommunication, robotic, and energy, power, and then also cyber, cyber security, and the future internet, and biomedical engineering. So all the branch of electrical engineering are having in this program. Okay, without further ado, I invite Dr. Muhammad Asfial as a Vice Dean for Academic Affairs in Faculty of Engineering, University of Indonesia, to give the welcome speech. Please, Dr. Asfial, the time is yours.
Okay, thank you very much, Pak Surya Negara. Assalamualaikum warahmatullahi wabarakatuh. Good morning, Mr. Ramesh Rao, in USA, and now, at night in Indonesia. So good evening to everyone, in Indonesia. Honorables, Mr. Ramesh Rao as Senior Director of Engineering Qualcomm in San Diego, USA. Just information to Mr. Ramesh Rao, in 2006, when I joined in the conference in San Diego, I visited Qualcomm also in San Diego, I have a friend, he he worked here in Qualcomm San Diego. His name is Sahriza Andiko. Do you know him, Mr. Rao, Sahriza Andiko?
Yes, I know him.
Oh yeah, okay,
Yeah.
It's great. He is my friend. When I studied in senior high school. In my in Bukit Tinggi. That is the village. My village in Indonesia, in West Sumatra. He is my friend. When I studied in senior high school. It's very happy for me. You spend your time to sharing us today for our student, to our researcher and also regulators. Pak Surya mentioned the participant in this public lecture is not only researcher and also student, but also come from regulators and also for telecommunication operators. And of course, listening guests and also all participants. It is a great honor and a pleasure for me to give a welcome speech in this event, public lecture from Mr. Ramesh Rao. This public lecture is dedicated to all researchers, regulators, and especially for our student, in Electrical Engineering Department, Faculty of Engineering, Universitas Indonesia. All participants, who has a concern with technological trend, in the next decade and touch upon in topic of 5G. This public lecture has organized by Electrical Engineering Faculty of Engineering, Universitas Indonesia. And just information for Mr. Rao, Universitas Indonesia is the oldest university in Indonesia, and also I think the biggest university in Indonesia. And of course, yeah, based on the Time Higher Education ranking, yeah, Universitas Indonesia is the top-ranked university in Indonesia. Globalization today, yeah, result in very competitive atmosphere, yeah, in all aspects, yeah, including the competition of new technologies, yeah, in telecommunication, both terrestrial and also satellite communication. Public lecture today, yeah, the topic is very, very interesting. We are here at Universitas Indonesia is very concerned, yeah, with the wireless and mobile communication development, and of course, yeah, including the 5G technology. In telecommunication, 5G is the first generation technology standard, yeah, for broadband cellular network, with cellular phone companies here began deploying worldwide in 2019, I think, and is the plan they are successful to the 4G network, which provide connectivity here to most current cell phones. 5G wireless technology is meant to deliver higher multi-gigabit per second, yeah, peak data speed, yeah, ultra low latency, more reliability, yeah, massive network capacity, yeah, increased availability, and more uniform user experience, yeah, to more users. Higher performance, yeah, and improve efficiency, empower new user experiences, and connect, yeah, new industry. And I believe and I think, yeah, more detail about the 5G trend technology, yeah, will be explained, yeah, by Mr. Ramesh Rao, yeah, for public lecture today. Okay, all participants, yeah, with such intent and friendly discussion, yeah, I expect, yeah, that this public lecture would become a forum for us, for our students, yeah, and researchers, yeah, to be efficiently involved, yeah, in wireless and mobile technology development. In this moment, I would like to extend my sincere thanks to Mr. Ramesh Rao for your time, yeah, for your sharing us related, yeah, to this topic today, yeah, 5G trend technology. Hopefully, yeah, Mr. Ramesh Rao, yeah, in future you have time, yeah, to visit us, yeah, to visit Indonesia, and of course, yeah, to visit our campus, yeah, Universitas Indonesia. I would also thanks, yeah, to our colleagues from Electrical Engineering Department, Faculty of Engineering, Universitas Indonesia, yeah, for their great support, yeah, for these public lecture events. In concluding, I wish you every success, yeah, in our public lecture today, yeah, and our discussions. And thank you very much, Pak Surya Negara, yeah, organized, yeah, for this public lecture, and also Pak Aris Subiantoro, yeah, a head of Electrical Engineering Department, Faculty of Engineering, Universitas Indonesia. Hope you enjoy, yeah, to all participants, yeah, for public lectures. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Go back to Pak Surya Negara.
Yeah.
Waalaikumsalam.
Thank you, Pak Asfial. So yeah, all the participants. So the time is now already 7:18. So I invite Mr. Ramesh Rao to give the lecture, and then we continue with the discussion. Please, Mr. Ramesh, the time is yours.
Thank you.
Okay.
Susanto, can you share the screen, please?
Yes. Okay, is it showing?
Yep. Good evening, students, faculty members, and industry colleagues in Indonesia. Really glad for having this opportunity to present technology trends for an intelligently connected world at this particular time. I know we are dealing with a lot of uncertainty with the pandemic, etc. I pray and hope everyone is safe and healthy, and wish you all success in your future, in your engineering future, I would say. My talk today will focus on the technology trends and the skill set that you will need to have in your arsenal for the next decade. Technology is extremely fast changing. It's always moving on to faster, better, low power technology direction. And having the skill sets to tackle what is there in the future is going to be very important, especially for undergraduate and graduate students who are going to be graduating soon, or who are yet to make up their minds on what is their passion and what they want to pursue in their engineering futures. Susanto, next slide, please. Next one. Okay. So my talk today is going to focus on 4 core areas. Okay. This is going to be intelligence. It's going to be connectivity. It's going to be mobile, and it's going to be highly integrated. I will hopefully explain to you all these 4 terms, what it means, and how they all play together. Okay. Now, I'm going to go back to the previous slide, please. Intelligence is extremely necessary now. It's not just important or just enough to be connected. Okay. In these times where we have not been able to meet each other or connect with each other face to face, I think everybody clearly understands that connectivity is going to be the basic fabric that connects any society and propels it to the next phase of development. Intelligence is something that is getting added to this, and it's just not enough to be connected. We need to be intelligently connected, especially when we're talking about device-to-device communication. I think it will be good to be intelligently connected. And again, mobile, we don't have to explain this part, right? 20 years ago, 30 years ago, it was just enough to be connected. Now everybody expects to be connected even when they are mobile, right? This is a big paradigm shift. Earlier, it used to be that there were very few analog phones that were connected to these exchanges or telephone exchanges, and you had very limited connectivity, you had very limited accessibility to the telephones, etc. Today, everyone basically has a mobile, and that is, it's going to be the trend of the future. Again, mobile is just one example of, smartphone or phones are just, mobile phones are just one example of the mobile nature of communication, but that is going to be an ingredient for the next generation, the next few decades. Highly integrated, what we mean by that. Gone are the days when you could have bulky products, right? You want to put everything into very, very small circuitry. You want to basically bring in the lowest power adaptations that are possible to make the units truly mobile. You want these to survive on very minimal battery power. So these are all technologies that will show up in my next slide. Sujanta, can you go to the next slide, please? So going back to the 4 ingredients that we spoke about earlier, we will now talk about what those core technologies are. Right, we're talking about connectivity, and 5G is going to be one of the fabrics of defining that connectivity platform. Intelligence is going to be defined by artificial intelligence, machine learning, deep learning, etc. So these are what are going to be the fundamental technologies you need to master or to learn in order to be successful over the next generation, right? Next few decades are going to be very, very, you're going to see a lot of developments, you're going to see a lot of progress in these areas. Compute, again, compute has been there for since the 80s. Compute has been there since the 70s, 80s. We've been progressing on compute. It's primarily been PCs and processing in the early 80s. Now it's been moving to heterogeneous SoCs or systems on computers or system on a chip. And again, compute just by itself is not enough anymore. You will need to have graphics capabilities. You'll need to have CPU capabilities. You'll need to have DSP for low power. You will need to have several other multimedia processing. You need to have camera processing, ISPs, a lot of all these things need to operate together along with the basic compute. So compute needs to be looked at in terms of VLSI design. You need to look at it from a perspective of miniaturization, in terms of integration, in terms of analog circuitry, power circuitry, etc. So there's lots of applications for compute, and hopefully there are many people in the undergraduate and graduate programs that are actually focusing in on these aspects. Low power becomes another critical component of this whole thing. Low power is absolutely necessary, right? You charge your phone perhaps once a day, and the modern phones, you expect it to last for at least a couple of days. And fast charging, right? That is a requirement these days. Again, earlier it used to be that the previous generation, or the 2-3 generations ago, the requirement was such that you would be acceptable of anything that would give you a decent amount of charge. But nowadays the demands have increased and the processing capability has increased. So you need to have lots more available power to help operate the futuristic devices of tomorrow. Along with power, there's battery technology, there's batteries, there is charging related technologies, etc. And then we move on to antenna, RF, etc. So this is another big area that is of development, right? You have array antennas, you have MIMO technologies, you have analog circuitries, you have transceivers. I mean, the one basic thing that has not changed is the concept of the radio, right? You need a transmitter, you need a receiver, you need an antenna, you need a front end. That concept will never go away. It can be miniaturized, it can be packaged into different partitions, etc. But the basic concept of the radio still prevails, and it will prevail in the future as well. So how do we adapt to newer MIMO technologies? Are we going to do array antennas? Are we going to do beam combining? Are we going to do beam monitoring? These are all technologies that we'll talk to about the RF. How are we going to look at propagation characteristics? How are we going to design base stations? And how are we going to operate all of our networks, not just mobile networks, satellite networks, anything connected to radio will have to employ some kind of RF. Then we move on to 3 other technologies which are extremely important. So with completely decentralized and mobile products, and with the surface area of IoT products having increased the touch points or the number of accessible points to any malicious, like it can be a virus, it can be a bad player, it can be somebody, a hacker, it can be anyone, right? But you need security on these devices. You need security to protect the devices. You need security to guarantee that the software that is running is clean. And you need security to make sure that all the private data that you collect, the data that you collect from the networks, the data that you collect from the peripheral area, the health devices that you are looking for IoT, they're all very, very critical to maintain. That will be you need these devices to be very secure, because they are an extension of your own self. You're going to enter a lot of private information, your emails, your photographs. You don't want unauthorized people to access any of that information. Multimedia is again a huge component. I mean, 30 years ago or 20 years ago, if anybody would have told you that you would be roaming around with a camera all the time, you would have laughed. But today it is reality. Smartphones have made that a necessity. Anything and everything is pretty much streamed live for the world to see. You want to share your moments with others. Social media is driving a lot of connectivity. You want to share what you ate. You want to share where you are. You want to share the beautiful sunset. You want to share a lot of things connected with your life to the people you care. So that is all that multimedia brings. Again, multimedia includes audio, video, anything related to the ISP, anything related to the camera lenses, any of those aspects like compression, and any of these areas are going to be covered under multimedia. And then there is a huge underlying thing called software. Software pretty much covers all of these areas and more. And again, the new paradigm.
Saya beli? Sebentar ya.
Can I request the
Bun, apa
participants?
kita beli aku?
Please mute all the participants.
Yeah, so another paradigm shift in this entire software thing is earlier software was in floppy disks, for those who remember that phase. Then we moved on to CDs and DVDs for aggregating larger content distribution. And then it was wired networks, Ethernet servers, they were popular. Today, everything is on the cloud. So internet, with the advent of the internet and with the advent of cloud services, all the software and services and applications are today available to your devices from the cloud. You don't need media to distribute it. So anything and everything that will be connected will be eventually connected to the internet and the cloud infrastructure. Again, cloud could have many forms. It could be the central cloud, it could be the edge cloud, and there are all of these variations that give you the best possible scenarios for your applications and how you set up your latencies, how you what latencies you need, what performance is needed, how much processing power is required, etc. All of these are the core technologies. And again, this is not all of it. This is just a sampling that I'm giving you that I believe is going to be the future and is an area that I work in on a daily basis. So as you know, I work in Qualcomm, and we have a lot of these technologies as the development areas within our company. We have several products, we have several technologies, and we have a lot of IP in these areas. So this is something that I am familiar with, so I'm talking about these areas. There might be a lot more beyond this, but these are like fundamental technologies that will differentiate your preparedness to be ready for the next decade. Again, mastering this, some of this, all of this, and specializing in a few of these areas will definitely be a very good start as you prepare for your careers going forward in engineering. You will be taught several curriculum courses in these areas. So again, I don't know specifically what will be taught in these areas, but again, the fundamentals are all going to be covered in your university programs. As you go into graduate, as you do your research programs, etc., you will be touching into a lot of depth in these areas. I encourage you to think about these areas as possible sectors that you can contribute going forward in the engineering field. Again, a lot of these fundamental core technologies are what will contribute to the changed, digitally transformed verticals that we see today. I will touch upon some of these areas that are undergoing massive transformation. So you will think about healthcare, you can talk about automotive, you can talk about gaming, video streaming, virtual presence, connected home, industrial, etc. All of these are going to be massive areas that are seeing a lot of changes, especially in the last 18 months during the pandemic. Even when we were isolated and forced to stay indoors, technology allowed us to communicate, connect, and take care of people, right? Healthcare became completely a connected entity. So earlier, healthcare was face-to-face. You used to go visit a doctor, but the pandemic made it a situation where you could not go and get diagnosed for all cases in a face-to-face manner. So a lot of these health e-checks, healthcare wearables, connected home, where you took all of the, your meetings and you participated in your schooling, your education was through your home, and everything relied on connectivity. So this is something that we are going to be kind of living with for the future, right? The pandemic, if it has done anything good, it has accelerated the digital transformation of several verticals. Again, I'm going to go into some of these verticals in the next few slides, and we will cover what specific core technologies are going to be there and how these things will work, and as we see the digital transformation on these verticals. Siddhanta, next slide, please. Okay, so talking about connectivity, again, as I explained, 5G is going to be the basic technology that will be disrupting pretty much everything that we have until now, right? We had 2G, where it was just digital voice and SMS were the services. 3G gave us access to the internet. And 4G is where mobile apps were born, right? You looked at the apps that came out. You could hail a cab with the Uber. You could do social networking through your Facebook app. And all of these required a very, very high rate of data rate and a highly, I mean, and you needed constant internet access to do some of these things. So that was what we enabled in 4G. In 5G, what happens is there are going to be three basic pillars that will emerge, right? Enhanced mobile broadband is one of them. This is going to be primarily data rates, average throughputs, reduced latencies, etc. And that is going to be on the smartphone side. Then you will have mission critical services. And this is where things will be ultra reliable, low latency communication. You would have heard a term called URLLC. This is where your mission critical services will be coming through. Then you have something called massive Internet of Things. This is where machines will, you will have a massive deployment, 1 million deployments within a kilometer of area, a kilometer square area, right? So this is a lot of IoT related products. So when I talk of IoT, it's Internet of Things, it's any devices, it's machine-to-machine communication that happens, it's sensors, it's security systems, it's healthcare units, it's monitors, it's cameras. You can talk about any of these being part of this IoT. And again, the global impact of 5G is according to studies, is basically going to be up to $13.2 trillion. So the impact is going to be massive on 5G. So learning on 5G, learning on different areas, learning about IoT, and those are all things that you can look at, right? Again, these are all going to require connectivity as a basic fabric. 5G is an underlying technology. And then you have other things that are going to be coming out of this one. So like I said, you'll be looking at ultra low energy that is required basically for IoT products that are operating in the middle of the desert or in remote areas. You don't want to be changing the battery on these. You don't have a way to charge these batteries in many cases. So you want multiple years of life from these batteries. Again, the system is designed on 5G in such a way that it can scale across multiple classes of services, right? So what will be required for a low data rate IoT device is going to be completely different. And again, security is an underlying theme that will hit all of these technologies. It's still the same one. And you're going to have a lot of very dense deployments, and that will actually lead to a lot of network architecture and other areas of innovation as well. Go to the next slide, please. Okay, now we spoke about 5G, and 5G is basically like the fabric that operates on a diverse spectrum, right? You can operate it on low bands, you can operate it on mid bands, and you can operate it on high bands. And then you have many ways of deploying. You have any multiple ways of deploying your 5G, right? It doesn't have to be just an operator deployed scenario. It can be a private network. It can be in a vehicular access network. It can be through array antennas. It can be through a fixed wireless access deployment. So there's several ways and use cases for these diverse deployments. What it provides you is very low latencies. It gives you a lot of uniform average high throughputs. The traffic capacity of the networks has increased significantly, and your peak data rates are also going to be in terms of gigabits per second, right? So that is what you would expect. And all of these are part of what we call the 5G new radio concept, which is currently at release 15, and release 16 is going to be out by the end of the year. You'll have products supporting release 16. And 3GPP will be coming up with 17, 18, 19, etc. as we move into the next few years. So by the end of this, until probably the end of this decade, you will see all of the 5G deployments taking massive effect in several areas, including Indonesia. Indonesia has already started on 5G. There are several carriers deploying 5G right now. So it is a good time to look at learning up, reading up on 5G, on the technology, and seeing where you can actually contribute in those areas. So that's going to be something that you can look for as an potential area where you can develop expertise in. Next slide, please. So this is, again, going back to different ways of deploying the factories of the future and everything else, right? This is going back to everything is intelligently connected. You have you can provide private networks with 5G if you have an arena, if you have a stadium where you want a massive millimeter wave connectivity based 5G, then that is probably a good option to look at a millimeter wave deployment scenario. If you want an indoor enterprise kind of thing for a university connection, or if you want it for an office building or an apartment, right? Those are all another way to deploy it. Fixed wireless access will give you fiber-like quality with a wireless 5G medium. So that is going to be another one. Factories, smart factories is another one. Smart transportation, which we'll go into a little later, is another aspect of it. So we have several ways of deploying 5G, but ultimately the vision is everything is intelligently connected, right? Everything meaning all the different IoTs, the devices, the networks, the mobile edge cloud, the central cloud, they're all connected and intelligently exchanging data. Go to the next slide, please. Okay, now let's get into AI. So what is AI, right? We have, so you're trying to basically bring what a human intelligence allows into a machine. So human beings can perceive, we can reason, we can act based on what our reasoning capacity tells us to. That is the same behavior we're trying to bring in machines, right? So we have perception, which is enabled through a multiple variety of sensors. It can be a camera, it can be a temperature sensor, it can be a humidity sensor, it can be a GPS for a location awareness. It can be an accelerometer that detects motion. So you basically are sensing your surroundings, right? You can sense it through various technologies. Your smartphone does most of it at this point. You have several sensors embedded in your smartphone, and they all detect the surrounding and environment around you. So what do you do with this data? You want to actually then, do you want to detect something? You want to reason with it. Okay, the temperature is too high. Maybe I turn on the air conditioner. It is starting to I'm starting to move. Therefore, I might start counting my steps, right? I'm detecting that I'm in my home, so I want to turn on the lights when I come into my home. So all of these are basically what you are doing to reason. So once you get the inputs, you reason with it, then you figure out what you want to do with it. You can turn on the lights. You can basically look at creating an action that is a response and to the perceived information, and you want to bring in a reaction to it. So all of these paired together is something that defines human intelligence, and that is something that you're trying to imbibe in a machine. So that is your machine learning. This is your artificial intelligence requirement. And today we have this in the palm of our hands, right? And one of the key things that enables this, you need a lot of compute power to do some of this work. Your machine models that you develop, your machine learning, your AI models, your deep learning models that you develop are actually very compute intensive. They need a lot of computational ability to run. They're all power intensive as well. So with this, you need compute in this micro devices. So this is something that has been enabled already, and Qualcomm has done a lot of research and enabled compute and massive availability of computation in these processors that we have on our smartphones today. And that is something that is another very interesting technology in the future. Go to the next slide, please. So now when you connect you have devices that are sitting with everyone. You have your sensors, you have your IoT devices, you have your smartphones. They are all sitting with each other, deployed in thousands and millions. And then you have something called a cloud. So as I said earlier, all the software, all the applications, they reside on the cloud. How do you connect to it? Earlier, it used to be only wired connectivity, right? Then we got to 3G and we got to 2G, 3G, and 4G, which gave us this connection pipe. But today we have 5G. So when you put 5G and AI together, it makes us seamlessly connect to the cloud, right? And that is a huge advantage going forward to look at and develop several use cases. Again, when you put AI and 5G together, they are complementary solutions that make for a very powerful combination. With this, you can get into manufacturing, robotics, security, healthcare, driver safety. A lot of areas can now be completely transformed and innovated to offer more safety, more security, and take all of these technologies that were very dormant for a very long time. We can now take this and innovate immensely on it. Right, so this is another fantastic opportunity. Again, you're talking about cloud engineering here. You're talking about software technologies here. You're developing AI as a technology. You're getting into deep learning. You're getting into RF. So you have all of these areas that you can actually specialize in and think about how you put them together, right, as part of your future. This is another very interesting area. And again, I believe we are only scratching the surface of all the applications at this point. We have not yet come up with the killer applications that will be coming out. Once we come up with that killer application, there will be much more innovation coming in this space. So this is definitely another very strong area to look into. Going to the next slide, please. So the concept of AI and 5G, we've spoken about all of those things, right? So now we look at all of this, and now it is possible to put this whole thing together in compact mobile devices, right? What makes it possible? You have the power efficiencies required to run on device and do efficient compute on device. You have the silicon process nodes that allow you to operate at very low voltages, drawing minimal power. You have very efficient learning techniques, deep learning, reinforced learning, etc. You have GAN networks. You have several advances in AI ML techniques. All of those allow you to bring in very small models. You have something called tiny ML, which is basically reducing the footprint of these modules to operate on very small, low power, small footprint devices. So that is another area. And then we have, from an architecture perspective, the system is now ready for bringing in a lot more software innovations. You bring in a lot more techniques that can make this even better. So let's look at how this is going to, with AI and 5G, with the ability to perceive, reason, and act upon, what that does do to IoT, to mobile and automotive. Next slide, please. So now, again, just giving you an example here, right? So in your smartphones today, you can go focus on an image with your camera, and your camera will recognize whether it is a scene or if it is an individual picture, and it will bring in the right kind of settings required for the camera to get the best positive results in terms of taking the best photograph that you want, right? It can be you're taking a close-up of your kid's picture, or you're taking a scenery of a sunset. You have the settings that automatically happen on your camera. And that is just one example of how you do this, right? And you can do much more things with this. Next slide, please. So again, we go back to the concept of everything is being intelligently connected. Now you hopefully understand what I mean by intelligently connected, right? That is the paradigm we are shifting to. We're going into a world where everything is intelligently connected and intelligently operating with each other, right? There are all of these things. You're basically collecting data from a sensor, storing it on a device, and once you have a network that is ready to be updated with this information, you send it as a packet. So that is one way to do this. Next slide, please. Now we'll talk about a concept called a driving distributed intelligence. So we spoke about the cloud server. We spoke about and cloud server is basically a centralized data farm. You don't have any limitations on the amount of power you can consume because you're connected to the mains power, right? It's not mobile, it's a stationary, you're connected to a server platform somewhere in the cloud on the internet. So there's not much of a power requirement with that. You have immense computational capabilities. You have pretty much unlimited amounts of data. Let's assume that. And then you have a lot of processing running on your distributed server. So today, when you type in an email on Google, it prompts you to fill in the sentence for you, right? That is coming from your centralized server. Your centralized server looks at your inputs and it basically prompts you to complete the sentence based on what you're typing. That is some kind of intelligence that is there on the central server. Here, latency is not a major issue. That use case can survive with a limited, with a lengthy latency, right? And then you have the other end, which is on device. The camera example that I gave you, where we are focusing on an elephant, and the system detects that you're taking a picture of an elephant and makes the changes on device without having to contact the cloud, right? It does all the intelligence is on the device. But what if you had the best of both worlds? You have a 5G connectivity stream that is available to you because of the 5G technology and the low latencies that it offers. It gives you the bandwidth to connect to the cloud as well. But going to the cloud and coming back, the latency, the round trip delay is going to be significant. What if you had an intermediate junction where you could have a mobile intelligent, a mobile edge cloud, right? So it's the same cloud available on the mobile edge. And the biggest advantage with this is you reduce your latency significantly, because now you only really have to travel half the distance instead of going the full loop. That is one. The second one, you can have this mobile intelligent edge device on your premise, right? So you don't have to go to a Google or a central server that is not in your control. You might as well go to a server that is there in your enterprise, it's there in your home, and that way you basically keep all the data and the smarts exchanged with only your edge cloud instead of going to the central cloud. Central cloud is not in your control. Edge cloud, you may make that a part of your network and be able to keep your data more secure. So that way you can protect that edge server and you're bringing in security. So this is an aspect of, again, talking about cloud services, you're talking about 5G as we spoke about before, you're talking about the device, you're talking about low power, and you're also talking about now a new concept called mobile edge cloud, where security becomes very prime. So this is a new aspect that you want to consider as well. So as networks become more and more prevalent, and you have IoT and you have private networks, this concept is going to be something that is going to massively develop in the next decade. And this is something that we're already seeing taking off. A lot of services, a lot of gaming that require low latencies will operate in this mode, right? You want to have a seamless connect, and to the device, it should not matter. To the user, it should be entirely transparent on how they connect to one another, right? So you can make that possible with this edge cloud concept. Can you go to the next slide, please? And now we'll talk about some daily experiences that we will be transforming based on that. So your phones are always connected to the internet 24/7. That has happened since about 10 years ago. Since 4G days, you have that connect. Your application downloads, you're doing that every day. right? Again, you don't know where these applications are residing. They're residing somewhere in the internet. The app store is residing on the internet, but you have the ability to connect very quickly and download something. And it's as if you never, you always have everything resident on your smartphone. That is the beauty of it. You have location services on your device. You can enable video streaming. You have facial recognition technology, right? Today, you open your devices, your Samsung devices, your iPhone devices, you have facial recognition, right? And that is basically an application of security, it's application of software, it's application of AI, it's application of multimedia, camera, etc. So a lot of these technologies are prevalent in just that one use case. And imaging and photo capture, you're doing that all the time and uploading these pictures to your repositories, either Google or Amazon or iPhones, wherever your iCloud, wherever it goes to. Again, you're talking about battery and management and power efficiency. Again, you're listening to music all the time. You're watching movies, right? You're looking at all the audio effects that accompany it. So all of these are part of your daily experiences, which you have come to expect, and you will be going with that. You'll be assuming these are available to you all the time. Next slide, please. Yeah, so this is about the connected home. I'm sure you all have connected homes at this point, right? You pretty much expect fast, reliable, secure internet connections. And again, these don't have to be some things that are only going through a DSL line or a cable modem anymore. You can have a 5G hotspot or a 5G MiFi device or a CPE as a consumer premise equipment, and you can get the same services now. So that is something that is very applicable to the current pandemic situation we are in. It may have been that 18 months ago, before the pandemic started, people lived with a low-speed connect. But today, everyone expects high-speed connection. They work from home, they study from home. This is part of the enablement that has come out because of all of these technologies and 5G as a connectivity medium. Next slide, please. And again, we're talking about the future of productivity, right? So once you see that there is mobility, connective technologies coming together, we are looking at what the next transition will be, right? So you're getting into a world where you're looking at a mobile-first environment. You're talking about unlimited cloud compute resources that are available to you. You're talking about virtual experiences. So today you can participate in meetings through any of the virtual reality, augmented reality kind of setups, right? You can have your digital avatar actually participating in meetings. You can join into hybrid education sessions. Your classroom is going on, and there will be soon a point where you can actually do something like teleportation, right? This was something that was happening before in science fictions. That will soon become reality today. You have the way to do this, and with high quality cameras, with displays, from virtual meetings to gaming, to participating on streaming platforms for entertainment. All of these is possible as part of the requirements for productivity in the future. Next slide, please. So again, just giving you some stats on where we are today. Because of the pandemic, in the recent the numbers that we had 1.7 billion students studying remotely and 1 billion telehealth that happened in 2020. Right. This is, again, like I told you, one of the changes that we've seen with the pandemic, and something that has been entirely enabled by all of these technologies we are looking at. Next slide. Let's skip this. Go to the next slide, please. Okay, now we'll talk about cloud gaming, VR and AR. We're calling AR and VR boundless AR and VR in this case. I'll explain to you what that is. Again, this is all enabled by 5G, and these are like all architectures based on processing between the device, the cloud, and low latency that is required. So those are probably the use cases that you'll begin to see. Go to the next slide, please. So you've heard about the term XR. XR is nothing but AR plus VR together. So augmented reality and virtual reality together is what we call XR. So this allows you to wear these headsets. And again, you can have them PC. You can either have a standalone XR, which is called mobile XR, or you can have something called PC tethered XR, which is connected to your PC. The reason you need PC tethered XR is for all the processing happens on the PC, which has a lot of the processing capabilities, but you're connecting back to the system through a wired cable. It doesn't allow you maximum flexibility in terms of roaming around, etc. And some of these actions that you do are limited, but it gives you the experience, right? Together, if you can combine these two, you create what is basically the best of both worlds in terms of the higher processing capability and the freedom that you get with XR, where you can you're not restricted to the length of the cable connecting to your PC. So that is basically what XR is. And XR actually does split rendering. We'll get into the split rendering concept on the next slide. So you have your XR, your person wearing your XR headset, and the computation is actually distributed between the edge cloud server, which is here, and the device and the device to it and the device, right? So you have a 5G tower here. All of your so when the XR user moves his head, the on-device processing kicks in, and all of the information about the pose, the head pose, etc., is sent to the edge cloud through the low latency link. So all of the information gathered on this device, based on the on-device processing, is sent to the edge cloud. The edge cloud uses the head pose to partially render the next frame. So based on your orientation of your head and the way you're turning, the edge cloud is able to process and render the next frame, and that next frame is then seamlessly downloaded to the device, and the device display that you have on the headset actually projects the next frame here. So what we are doing here is basically you have some on-device processing, you have the edge cloud doing the rendering for the next frame, and you're basically creating a seamless effect. So this is how you distribute the computation between the edge cloud server and the device to bring in a truly immersive experience for the user. Now he can be so I could have, if I was using an AR glasses and been in this meeting, I could have literally been amongst you in the auditorium. If you are all assembled in the auditorium, I could be there, right? If I turn my head left, I would have seen the people situated on the left side of the stage. If I turn right, I could see the people situated on the right side. Again, this is a lot of multimedia, a lot of cloud services, a lot of 5G, a lot of engineering to do a very small footprint design on the silicon, etc., with the headset. So a lot of engineering goes into this, and this is another huge area that we will be going to this technology. So where are we going with this? Go to the next slide, please. So you would have heard news that several companies are working on AR glasses, right? So this is where we're going with it. So you will have a very high-powered display. You will have cameras that are connected on the glasses. You'll have some on-device processing that's happening, and you'll have battery capability. And you will have the ability to connect through a 5G wireless link back to the processing center. It could be the other device, it could be the cloud network, it could be however you set it up based on your architecture. But the end result is you can wear this and now walk around, just like how you were wearing your prescription glasses. You can do the same thing with these AR glasses. And this offers a different set of capabilities now, and a lot of innovation can happen on this one. Go to the next slide, please. So you can you can wear these glasses and go into a retail space, and you can look at, let's say, a display on a store shelf, right? When you look at this display, you can get at all the different colors that are available, because the smart glasses has a camera The camera looks at the device, it looks at what this is, and it understands that it's looking at a dress that is gray and blue in color, and it tells, and it basically device does the processing and contacts the edge cloud and gets the information that these are the other colors available, this is the pricing, this is the number of sets we have, and these are the other accessories that go with this design, etc. So entire retail space, the shopping space, your online e-commerce, all of those can benefit from this one. So that is just one use case. Again, all the technologies that we spoke about are completely applicable on this scenario. Go to the next slide, please. So again, 5G cloud gaming is a very similar experience. Cloud gaming is a massive industry that is popping up. Gaming itself, mobile gaming is a massive industry that's coming up through. And in this space, there is a lot of requirements that are coming because of 5G has enabled this space and allowed it to connect to the cloud. Gaming experiences have massively improved. Display, multimedia, gaming software, and all of those technologies come into the picture here. It is a very similar concept. Go to the next slide, please. It's a very similar concept as what we did before on the split rendering. This is the same technology that distributes the computation between the edge server and your 5G device and your on device. So you basically combine the two to bring console quality gaming. So what you could earlier do through your Xboxes, etc., you can actually do a lot of this with your current mobile devices. And this is something that is also a massive area that is coming up for development. So if you're interested in gaming, if you're interested in working on these technologies, this might be an area to consider. Next slide, please. Okay, so now Boundless XR, in terms of all the things we spoke about, the shopping experience, you can basically do mobile meetings, you can do, basically you can be there anywhere. This is multiplayer gaming, and then you can collaborate, right? Let's say we were working on a research project together, you are in Indonesia, I'm in San Diego. We can do this collaboration through the system, through the 5G system, to the application, however we design, or a Teams meeting, and both of us could be looking at the same lab results, right? You could be browsing the lab results, and I could be looking at what you're looking at to collaborate more efficiently. So this is just a few applications we're talking about. Next slide, please. Talking quickly about healthcare. Again, healthcare has seen massive strides over the last year and a half, primarily driven by the pandemic, where we could not see a doctor directly. So you can enable them with the cloud. You can have wearables. You have all of these heart rate monitors. You have all of these blood pressure monitors that talk to and collect data on you and report it to your doctor's office seamlessly. You want to keep security and privacy as major concerns here, because a lot of the countries have privacy laws when it comes to medical requirements and medical infrastructure. So that is another major requirement here. And we collect massive amounts of data. So you want to bring in AI algorithms. You want to bring in smart ways of looking at alarms. So if you're collecting your blood pressure 10 times a day, that data might, as long as it's within the bounds of a normal blood pressure system, right? If you have the 80/120 for a normal person, you should be okay. There's no reason to flag anybody. You don't have to flag your medical nurse or doctor in the hospital, etc. But if there is an anomaly that is detected, then you want to flag. So you're collecting data in terms of massive amounts, but you're only reacting to the abnormalities. So that is one way to set up the system. And again, there's a lot of data processing here. There's a lot of AI here. There's a lot of ML here. And again, you always have the wearable or the smart device that is connected always on, right? It can be an ECG machine that is reporting the data. It can be a blood pressure machine. It can be your sugar level. So all of these things are developing now, especially in the last few years. Go to the next slide, please. Again, this is basically looking at your sugar level, right? So you basically want to make sure that you're monitoring your insulin, the amount of insulin that you take. you want to monitor that based on your real time. What is your sugar level? Then you take the appropriate number of milligrams of your insulin shot. So that is something that you can control with your device. So that is something that's already available. So that's one example of healthcare coming in, and this is a massive industry, right? So healthcare is pretty much any geography, any community will need this. So that's one. Go to the next one, please. Again, first responders, right? This is another healthcare scenario. Let's say there's been an accident, there's a car accident. As soon as you detect a car accident, you could have your smart traffic cameras or any of these devices that detect the accident, call for emergency supplies. They could call an ambulance, they could call a fire truck if it sees a fire, they could call a cop if they see a robbery going on or a looting going on. That can be done automatically. Your smart camera can detect the action. It can understand the scenario that this is an accident, that this is a health emergency, whatever, and it can transmit that information. And as it does that, it can collect information that will help the emergency physician, emergency paramedic, as he's approaching the traffic scene or the accident scene. He will know how many people are involved, what is going on, is there blood loss, do they need information to be transmitted back? So, and same thing, when the ambulance is carrying somebody who's injured in an accident back to the hospital for an emergency admission, before even the hospital reaches, ambulance reaches the hospital, he could transmit, this is the vital information, this is the heart rate, this is the picture, this is where he has a cut in his wound, or he has a fracture on his left leg, whatever. All that information can be transmitted even before the ambulance approaches the hospital. And again, all this saves vital minutes and seconds that are going to make the difference between life and death. So this is another use case that is prevalent in healthcare. So you can look at this. This is also already being used in many hospitals now. Again, specialist consultation in the hospital. Typically in rural areas, you might only have one hospital and you might not have the availability of specialists that are required to diagnose a serious condition. But if the information is available on a central server and 3 or 4 doctors can participate in coming up with the right diagnosis for a patient, it might be more useful and give a better chance of survival, or give more options for surgery for that patient. So that is another example. Next slide, please. Again, this is remote patient follow-up. We already touched on this use case. You can stay at home, send all your data. Your doctor will only call you back if there is a situation. If everything is okay, there's nothing to contact, but if there is something that we need to, if there's something abnormal, then we can do that. Next slide, please. Yeah, I'll wrap up in the next 5 minutes. I'll probably go very quickly through the next slide. So we're talking about industry here, industrial transformation, right? So we had a lot of advances with Industry 1.0 based on the steam engine and water power. 2.0 was basically you had access to electricity, your radio, railroads and telegraphs kicked in. 3.0 was the 20th century really, and that was your computers came in, right? Computers came in. 4.0 is going to be about mobile devices. It's going to be about massive number of IoT devices connected. So all of these are connected. This is an IoT device. This is a private network device. This is an AGV. This is another IoT application. You have your air quality here. You have a robot here. All of these are IoT devices, and they're all connected to a private network. And then all the data is gathered on an edge, mobile edge cloud that resides here. Everything is private within this network. Again, release 15 and release 16, we'll see a lot of these standards coming in for industrial automation and other things. So that is something that is a massive use case. Again, a lot of developing economies are using this technology to come up with use cases that are useful for them. Go to the next slide, please. Again, logistics is another huge use case. You have containers. You want to you want to track these assets. You want to monitor. Let's say you're transferring, you're moving some vaccines. You're moving some seafood. You want to actually maintain the right temperature. And how do you know you have actually maintained the right temperature throughout the 6-hour journey it took from the port to the distribution center? you want to collect the temperature, you want to collect all of this information, you want to upload it to the central cloud and monitor everything there. So that is another use case. You can track your trucks, you can provide safety information, you can check the fuel levels, you can decide when to send the trucks for maintenance, etc. All of those are possible because of your logistics use case, your transportation use cases. Next slide, please. Okay, this is going to be the last set of slides on the transportation. So transportation is again is undergoing a massive shift. Go to the next slide, please. So transportation again has telematics, in-car connectivity, infotainment, and ADAS. ADAS, I think you're all probably reading up on it or being familiar with it. This is autonomous driving. Infotainment is the ability of the car to basically have a lot of the multimedia features, right? So you want music in your car, you want location in your car, you want to be able to use the speakerphone in your car, right? You want to be able to do voice calls, etc. So all of that is your infotainment portion of it. In-car connectivity is required. You might want Wi-Fi in your car, right? You might want to have when you're traveling, you want to have access to your internet. You want to have everything there. And then telematics is about all the car data, the diagnostics, all of that information is sent to your car manufacturer so that they understand how the car is functioning. So all of these are enabled through connectivity. This is another massive use case. Your autonomous driving is a huge use case. AI, ML, cellular, RF, all of these technologies are involved in just this one use case. This can again be cameras, it can be displays and everything else. This is again about connectivity, your modems, your RF connectivity in the car. So go to the next slide, please. Next slide. Again, this is just a pictorial view of what I showed you before. Go to the next slide. That's my last slide. Again, I'm wrapping up my talk here. Hopefully, I've spoken to you about some of the technologies that are going to be very relevant to the future. And ultimately, whatever you do, you want to make sure that enriches the lives of your community, your surroundings, your people, right? Your country. So consider all of those and in the right context and see how best you can contribute your innovative ideas, generate IPs for your company, for your country, etc. And ultimately, you want to enrich the lives of every of the society that you're a part of as part of your contribution back to the society. So I'll wrap up here, Dr. Surya.
Thank you.
Welcome.
Thank you so much. Okay, thank you so much, Mr. Ramesh. So, okay, so we have already 7 questions. 8 question on the chat. You can see the chat panel, Mr. Ramesh. Yeah.
Yes.
Some questioning related to the implication, social implication, some cost and some technical. So I'm quite happy because this before the talk is end, so the question come. So it means that we already have our audience have a very great enthusiasm for following this lecture. So I think, oh, Pak Agus Bejo, okay. Yeah, it is an honor to have Pak Agus Bejo far from Yogyakarta. Yeah. So I give a special for Pak Agus Bejo to give a question because you don't type on the chat, yeah? You can open mic, Pak Agus.
Yeah, okay. Can you hear me?
Okay, please.
Yes.
Yeah.
After Pak Agus, then we move to the question on the panel.
Yeah.
Sure.
Yeah, okay. Thank you very much, Pak Surya. Nice to see you again. Long time no see. And also thank you so much, Mr. Ramesh Rao, for the nice talk. I have 2 questions. Maybe can be very short to answer. The first one, I just heard a few days ago from the media that it is rumored that Apple A13 will be released by capability to connect not only 4G, 5G, but also connection with low orbit satellite. And it is also rumored that it will be powered by Snapdragon, Qualcomm X60 baseband processor. I'm wondering, is that rumor is correct? That is my first question. And the second one, implementing additional engine inside system on chip usually will demand higher power consumption. Yeah, and what is the strategy to keep the power consumption is still lower? Meanwhile, we add more and more feature or more engines such as AI engine. Okay, that's my two questions. Thank you.
Okay, very good questions. On the first question, I pretty much read the same information that you read about the satellite connectivity enablement with Apple. Unfortunately, I will not be able to comment on any products or technology from Qualcomm on any of those things. So that's I would not be able to give you any answers on that particular thing. But what you read in the press is exactly what I read as well. So let's see what happens. So that being said, on your second question about increasing loading on the devices and what happens to the power, there are several aspects of it. Several innovative aspects have happened over the year to make even to make the smartphone possible. There were a lot of innovations that happened. So a few things I'd like to mention here. One is the process technology. So on the silicon process, things have evolved to a point where we started many years ago with maybe 28 nanometers. I'm just going back a few years. Again, it started way back with other products, but we had like 28 nanometers, and then we came down to 14 nanometers, and then we came down to 7 nanometers. And today's latest Snapdragon chips that have been released are 5 nanometer based. So what that does, as you know, is it reduces the process advancement, gives us some ability to add more densification of the silicon die. So we get more capabilities, more transistors can go into the die to enable new feature sets. That is one. And we can operate, because of the smaller process nodes, at lower voltages. So that gives us the headroom necessary for us to add processes, right? But you're right, at some point, adding new processes will mean more battery. So if you looked at devices, earlier devices used to consume, were packed with maybe 2000 milliamp hour batteries. Today's devices are coming more as a standard. You will see 3500 milliamp hour batteries, 4000 milliamp hour batteries, etc. So those are two. In addition to that, there are a lot of techniques that happen at the system level to minimize power. So we operate at the minimal voltages necessary in order to enable the certain features that are running on the device. So very smart algorithms are running on the device to shut off processes that are not running, that are not necessary. So if your device is simply sitting on the desk and doing nothing, it doesn't consume very much power. That is because all the blocks are put into a low power state. The software brings everything to a low power state. The minute you pick it up and the accelerometer senses motion, it starts to do certain action, and that's when you come up, right? Same thing. Unless you wake up the devices, you will not necessarily consume power. So even when you're talking, you shut off the display. When you take it, there are sensors like proximity sensors. When you go close to your face, it shuts off your display. So that consumes power. So there are a lot of smart ideas like this that help reduce the power. But you're right. Generally, when you increase the requirements on the features, you will have to spend power. But how you compensate for it and how you control the amount of power actively consumed is left to all the algorithms and all the smartness and the system solution that you develop.
Okay.
Thank you for the answer.
No problem.
Thank you, Dr. Agus and Mr. Ramesh. So I think we move to the question on the chat, Mr. Ramesh.
Yep.
And we can randomly pick, I think, from Mr. Satria Indrawan. Can you read on the last two questions on the panel? intelligently connected things with 5G. I have heard in several channels. Can you see that?
I'm scrolling through is.
Oh yeah, on the
I've
last.
heard in several channels media that and private security data breaches are one of the more common concern. Data breach, yes. Okay, that's a very good question. So yes, in terms of the capabilities of the device, and in terms of the security breaches that are occurring, as you increase the number of IoT devices, what you are actually doing is you're increasing the surface area of the attacks that are possible, right? So if bad elements want to break in, earlier it used to be only one server that they could hack into potentially. Now you have 100 devices that are connecting to the server that act as potential weak points in the overall structure. Yes, that is one way of looking at it. But however, what happens is there are a lot of ways you can secure your data, right? There are several ways you can do this. One, I think first of all, you need to make sure that the device has secure blocks on it. So you're doing certain ways to protect the device itself, right? And you have certain mechanisms on the device through hardware, through software, anti-spoofing mechanisms, anti-rollback mechanisms, etc., on the device that the vendor can provide. And the second thing is all of these OSs, typically like an Android device or a device, will on a quarterly basis need to be passed with the latest security software maintenance releases. So that is another way to protect the device. But in general, the governments of the country, the regulators are coming up with methods and policies to prevent and avoid data breaches within their country. So it is left to each policymaker and each government to come up with those own secure policies, whatever is appropriate for that particular government, right? So India has its own laws, US has its own laws, China has its own laws for security. I'm sure Indonesia also has its own laws for defining privacy and security requirements for devices, as well as networks and where data is stored, etc. So I think that is another angle to look at to solve the security. But yes, there needs to be security protection on the devices. That is something that will have to come. And as we increase the number of devices, as more and more devices get available for hacking, that is going to be a problem that we have to deal with. And already we are dealing with it, right? So you will see in general a lot more breaches reported in the press, a lot more banks being hacked, a lot more ransomware happening in many financial institutions, in many companies, etc. It is something that we will have to deal with. But it is a policy, it is a technology that needs refinement and development as things develop. That is why I included it as one of the things that we need to look for, and it is certainly an area that is that can handle a lot more innovation. Much more innovation can come into that area.
Yeah, in our magister program, Mr. Ramesh, just short information that we have a class specialized for the cyber security. So the specialization of this master degree have a cyber security, and
yes,
yeah, the interest from student. I mean the prospective student is quite high recently. Yeah.
Yeah.
So in Indonesian, this kind of security awareness is getting higher.
Yeah.
Okay, so I think we move to the question again. Somebody raised hand, I think, just now. Oh, okay, from Ina Madianingsih. Okay, please, you may open mic.
Hello. I already said it before because I can open my camera because I'm on my way. First of all, thank you for your information and for your great knowledge shared to me. My question is, when all technology is getting better, it means the movement of criminology, or how to detect, how to mitigate regarding to the criminal is getting better. So means this technology also help for forensic or for child abuse or sexual abuse or something. So what do you think? Is it this technology also help for the forensic, or I need your suggestion or more info
Yes.
about this. Okay.
The view about crime, yes, the crime and related.
Yeah, in general, I think if you have you can deploy AI solutions to for some of these things, right? The closest I can think of from a technology viewpoint is maybe a smart camera that is deployed that helps in many different situations. In fact, one of my roles is to work with startups from many different countries, and one of the startups that I worked with came up with these smart camera application that they deployed in ATMs, right? So every automated teller machine that you go to withdraw cash has this smart camera sitting in the ATM booth, and it detects that when somebody is attacked when trying to draw money, or if a robber comes in, the smart camera is capable of detecting like hand waving, or it detects when a person is in a horizontal position, somebody is hit on the head and he falls down. It detects certain things, and it actually calls the cops immediately. So that it's an AI smart solution that was designed for ATM security. I'm sure such things can be extended to other areas, but I have not specifically heard of anything about crime prevention. Is again part of the security areas. You can do it several ways, but I'm not really an expert on that. I'm more on the technology side, and the closest I can think of is a smart camera solution with AI technology that can actually do this for you with a wireless connect back to the cops or to the police, right? So things like that can be done. Other things that I've seen are nursery monitors, right? You have these smart cameras in schools, in nurseries, in elder homes, etc., where that helps the parents check in on what is going on with their children, what is going on with their kids in the classroom. They can watch live what is going on there. So those are like some approaches, but again, I'm sure there are other ideas that will come out of this.
Okay, thank you. I think that's answering your question, yeah, Bu Ina. Okay, thank you,
Yeah,
Mr.
thank you
Ramesh.
so much.
Yes, it's a very interesting from now we touch up to the crime prevention. And now I think we have a question again in the chat from Nanda Handaru. Okay, from Singapore, my old friend. Nanda Handaru, you are the first who typed the question on the chat. Are you still here? Or you want to open mic to give a question directly?
Yeah, I think
yeah,
that's
you're
fine.
here. Please.
Yes, I'm here.
It's better to
in
ask
general,
directly.
Mr. Rao, it's just about cost or pricing comparison with existing network. Of course, that with the faster network, with the faster data rate that we will have, we could have a lot more application and whatever future application that is possible for us. But if like we are to implement this onto the mass, then of course price and cost would be one of the key factor to be to be considered. So like is there any comment on, like, in general? I'm not talking about like in particular whatever cost or whatever data rate, I mean cost per data, but it's more on the in general, or what would it take for everyone to actually implement this technology in the future? Yeah.
Okay.
Thank you.
I would like to answer that question from two different perspectives. First one is the device cost. Okay, what you will see in the market today, again, you can do this research on your own. All the premium class devices that are in the market today are mostly 5G devices. This includes the iPhone 12. It includes the Samsung Galaxy S20 onwards. It includes all of the Xiaomi, Oppo, Vivo devices and Huawei devices. You can look at all of the premium segment devices. They are all 5G devices. And I don't think pricing wise, there was not anything noticeably different from what you paid for the 4G to the 5G, right? Overall features have increased. Manufacturers may have increased the pricing a little bit, but that is one data point. So today's premium devices are all 5G. They all support 5G. So that is one point. For 4G, when we initially came out with 4G, it took at least 2 to 3 years before the low-tier devices had 4G. 4G was still in the premium segment or the high segment devices, as we call it. But if you look at what happened in 5G, within a year or within 2 years after first premium class devices coming, there's already devices available today in the market that support 5G that are available for less than $200. So that is another data point I wanted to share with you. So that is from a device perspective. From a cost, from the carrier perspective, at least in the US, there has been no noticeable change on the pricing that I pay for either a 4G data plan or a 5G data plan. It's the same. Okay, so what I would like to convey with this information is that based on these 2 points, at least for the services that we are currently consuming in terms of voice, in terms of data, etc., there has been most operators and device manufacturers have not charged a premium to differentiate for 5G. 5G is just considered another high tier device requirement, and it's been enabled. That being said, when you go into the IoT devices and other things, it is yet to get to that point. There is just starting work that is happening on bringing 5G class devices into some of the low tier capabilities, low data rate capabilities, what you heard here as reduced cap, etc. Some of these verticals for industrial IoT, etc., will come later in the releases, right? So you will start seeing more of those vertical markets being focused on in the next few releases of 5G. Okay, hopefully that answers your question. But again, operators, when they come up with some premium services based on 5G, they could charge a service fee for those apps. That is not ruled out at this point. But right now, there is nothing that is being charged separately for a 5G connect versus a 4G connect.
Thank you,
Okay.
Mr. Rao.
Yes, the answer I think is quite related with the question from Pak Chandra Agung Prasetya. So, Pak Chandra, are you here? Do you want? Do you prefer
Yes.
to? Yeah, okay. Do you prefer to give a question directly, because I think it's still related with the cost issue of 5G. You are from PLN, right?
Yes.
Okay. So please, Pak Chandra.
Okay. Good evening. I would like to say significant change technology that we implement in PLN. You know, first and 2G technology in communication we use. In GSM technology like SMS. Then we move to 3G. And then the last we implemented 3G. And then about the cost is getting cheaper from per customers consumption price of what we have to pay. You know that PLN has more than 2 million customer. Yeah, that we have to connect with them, communicate to not only for billing but also how we identify the theft. The theft, and then also each customer has a very characteristic like they could produce PV photovoltaics that we have to communicate, can predict what energy for the next, something like that. I mean that we need a technology to deal with the customer with the very big big customer, yeah, but we have a problem in the cost for the communication. So maybe in your country that you have solve problem solving for this one, that we have now, we communicate only in what is satellite, not satellite, GSM, just communicating with, but we have a powered wide line in here, you know. Yes, we connected with on grid with a wire. So maybe or maybe you have any solution to reduce the cost. That's all. Maybe. Thank you.
Yeah, thank you. So PLN is the electric company, national electric company in Indonesia, and they have 200 million, isn't it? The customer.
Yes,
200 or 2 million.
260.
Oh, 260
millions
population,
yeah,
but
population.
but the subscriber of
Yes,
the PLN, I think
260
not
millions.
that much.
Yeah.
I think. Yeah, I mean this is about the electric meter, Mr. Ramesh. Yeah, usually they use the 2G, 3G to connect to the meter and grab some data. Then the question is whether 5G may reduce the cost.
Again, so 5G, so I'm pretty aware of the smart meters that are used with 4G, with NB IoT, etc. So for smart meters, I worked on those as well. You do not require high data rates for that. So you should be able to do with a narrowband IoT, low power, wide area networks, things like that are good enough for doing smart meters. That being said, you can collect data with some kind of a concentrator. So you can have like 500 homes that basically are talking on an RF mesh, perhaps to this device that acts as a gateway. And then that gateway device can be a 3G, 4G, or 5G device. And you can basically have one communication back to the central node from this gateway device. So this gateway device can serve 50, 100, 200, whatever your capabilities are. So you can build a hierarchical system to reduce your cost of data not data, the cost of cellular connectivity that you require to these gateway devices. That is one way of doing it. The second is, as I said, in future releases of 5G standards, there will be the ability for 5G to actually go into something called reduced cap devices or reduced capacity devices. It's called RedCap. It's a feature that is that is being worked on in 3GPP. It will come in release 17, I believe, if I'm correct. It'll basically be a release there, and that will give the ability for the 5G devices to support very low data rates. So that will be something that you can look forward to actually start using smart meters, etc., using 5G. But if you want to use higher data rate capabilities of the devices to collect the smart meter information, that is possible today. But then it would be better off to support it with narrowband IoT, LPWA technologies, rather than doing anything with other ones at this point.
Thank you.
Thank you, Mr. Ramesh. So at least now we move to the another technical question. Yeah, so we have so far 2-3 questions about cost, about the non-technical aspect. So now we move to the technical aspect. I think we have a question from, okay, your student, Mr. Ramesh, Mr. Listio Edi Prabowo.
Yes, I remember the name.
Okay, he's going to ask a very technical question. Okay, please, Mr. Leo.
Okay, hello, Mr. Ramesh. Warmly regard from me. I am your student from your previous Qualcomm course.
Yes,
okay.
I remember your name.
Okay.
Nice to see you again.
Thank you. Okay, as far as I know, Qualcomm is widely used on mobile device, wireless device, 5G technology, and so on. Even now, from the news I read, Qualcomm has succeeded in mass production of smartphone processor with a size of only 6 nanometers. So my question is, where is the main focus of Qualcomm research development in this 5G era? Because I know Qualcomm has a lot of technology to make new products and new technology. So I wonder what else big tech company like Qualcomm is trying to achieve. Thank you for the answer.
Okay, Mr. Ramesh, before answering his question, there is another question is quite related with him. Here is we have Nova Christian. Nova Christian, you're here? Nova Christian. Okay, otherwise I will read I don't know his or her question, this one. Okay, it's quite related. Hello, Mr. Ramesh. Thank you for your great presentation. Maybe my question is not very related with 5G, but the question is, as we know with Moore's law about the size of transistor, we have almost reached the maximum size and all quantum tunneling effect will take place. Have Qualcomm anticipated it? Have Qualcomm have on R&D for this issue? So I think it's a bit related, very details about the technical. Please, Mr. Ramesh.
Okay, yeah, let me start with Listio's question, and then I'll go into the second part of that other question about Moore's law. So the latest Snapdragon 800 tier product is a 5 nanometer product that we've already announced. So that is currently what we've announced. We continue to work on more newer process nodes for the next set of products. That has not been officially announced yet, so I will not be able to give you any information on that until the official announcements come. But yes, we continue to work on the most leading edge nodes that are offered by the fabs and the foundries. So we will be working on the latest nodes. Pretty much, I think there are 3 or 4 companies that are driving some of these leading nodes, and that will continue to be the case in the near future. So that is one. Besides so we have several divisions in Qualcomm. In Qualcomm, we have within Qualcomm, 2 large segments that we have are basically the Qualcomm CDMA technologies, which is the ASIC division, and that is more pertinent to actually these process nodes and other things. So they develop the ASICs that go into the cell phones. So that is one. And we have a Qualcomm technology licensing division, which develops actually and licenses fundamental technologies that are required for the entire mobile ecosystem to function. So that's the other role that we have. So we develop a lot of IP and we license the IP to all of the folks that want to use these technologies in their products. So those are the 2 main divisions. And within the Qualcomm CDMA technologies, or QCT as it's known, we have several groups that report. If you look at our latest quarterly results that were published just a few months ago, you'll probably see that. We have automotive as one group, that business segment that actually reports. So all of the automotive areas are in that space. So all of the automotive technologies I spoke about, infotainment, telematics, and then ADAS, etc. Those are all research and product developments that happen in that area. We have another group called IoT, which basically does everything from infrastructure to compute, to connectivity, to IoT, industrial IoT, etc. XR, ARVR, all of those are in another segment called IoT. And then we have something called RF front end, right? So this is basically all of the analog RF front end pieces that work for our product. So that is another area that we have a lot of work going on in. So it's, and in addition to all of these, we specialize, as you know, right from the inception of Qualcomm, we have been driving the communication technologies, and modem is another fundamental area that we contribute in. And again, all of these have to, in addition to this, we work with the standardization of new technologies and new ideas, and with 3GPP and other industry standard bodies, etc. So that is another area that we do. So there are several areas of research and development and product development going on in parallel within the company. And as you know, we have a pretty large engineering group, an R&D group that contributes into standards, develops products, releases hardware, software, etc. So a lot of those go on in parallel for our company. So that's hopefully that covers all of the areas Mr. Listio was requiring about. The other question about your Moore's law. Yes, Moore's law definitely was something that helped us a lot. I mean, we followed pretty much all the gains that Moore's law gave. So basically, doubled our processing capability and every few years, and it gave us the advantages of that. As we get towards the end of Moore's law, as per what the industry sources are claiming, the gains are reducing from Moore's law because we've reached pretty much 5 nanometer. The next nodes will be 4 nanometer, 3 nanometer, 2 nanometer, etc., which is the gains are going to be lesser and lesser as we go in. But there are several other techniques that the fabs and foundries are coming up with. Some of them are to deal with different architecture, different partitioning, and different other innovative ideas are coming up. You might have heard of something called gate all-around arrays. That's a new technique that's coming up in the fabs, and processes with 4 nanometer, 3 nanometer will start to see that in TSMC, Samsung fabs, etc. So these are again all new techniques that are coming in. We earlier used to have something called FinFET technologies, but now we're moving into this GAA technologies. There's another concept called chiplets that are coming up. So that's another new technology that will help gain more integration, etc. So yes, the massive gains that were possible earlier when we went from 28 nanometers to 14 nanometers to 10 nanometers, those big gains may be slowing a bit. But again, there are other technologies that will help recoup some of the slowing down of Moore's law, if you want to call it that, right? But Moore's law is still alive, and we do see the trend continuing. But the pace at which we get the gains may reduce. But again, innovative ideas could come in that will enable us to work around some of these end gains that we are seeing from Moore's law.
Okay. I think it's answering the question, yeah, Patio and Nova.
Yes, thank
Okay.
you. That's quite completely answered. Thank you for the answer, Mr. Ramesh.
So there is a okay. We have a many question here. We have a question here, Mr. Ramesh. It's quite interesting. Is there any possibility to use 5G in the middle of the sea? And because he said that to send data log from the sensor, because the sensor put on the middle of the sea, and how is it possible to use 5G to send that data? And what about the idea regarding placing a 5G tower in the middle of the sea?
Yes, the short answer to that question is yes. 5G will allow that to happen at some point in the near future, meaning in the next few releases, release 17, release 18, they are looking at a feature called NTN, which stands for non-terrestrial networks. It's another fancy way of saying satellite communications. Okay, so if you look up non-terrestrial communications, you can Google it, or you can go to 3GPP and look at it. There is some developments and work going on in 3GPP to standardize satellite communication uplink and downlink with 5G waveforms. So that work is happening. There's lots of areas that have been identified as some things that would need to be figured out before they can actually come up with a standard-based way to communicate with satellites using 5G. And that is the work that is currently going on in the standards bodies. So the answer to your question is there will not be a tower in the middle of the sea, but it will be a satellite link from a ship or somebody on a ship that is in the middle of nowhere that is actually talking to a satellite directly, and then basically coming down to a gateway or some kind of a link, a downlink endpoint to complete that communication channel. It can be used for data, and it can be used for voice and other services.
Is it considered as a 5G or just utilize the satellite and connect to the 5G network on the terrestrial? Or
no,
5G
it is a 5G based non-terrestrial network.
Oh, 5G based non-terrestrial network. Okay, okay. The future will be like that. So I think that another question from Jamie Susanto. For an archipelago country like Indonesia, he said that 5G has limitation in coverage. I think this, when located in the sea, satellite communication has limitation in latency. So I think this relate with that your answer just now, yeah, about bridging the limitation by using this satellite, 5G based satellite.
Yeah, NTN is something that could potentially help with that situation. But I think for a country like Indonesia, you have to figure out what is the right frequency to help with the coverages. And you'll also look at the densification necessary to achieve those performance levels. So I think it's going to be a network layout and a frequency determination exercise that needs to happen to come up with the right frequencies, right bands, and right number of base stations to be deployed, etc. Right, and the economics that are going to govern all of these. So ultimately, it has to be meaningful, right? You can come up with a paper exercise of doing certain things, but who will invest the money? Which operator will do that? What is their infrastructure capabilities, and how much are they willing to invest? All of those will have to figure into this discussion. But yes, there are several ways to resolve it, but it won't be any different than what was done on previous technologies, right? Again, the 5G system will offer you certain features. How you take advantage of it will be left to your deployments.
Okay. So, okay, now we move to the live question again. I think here we have Mr. Adipa Alim. You may open mic.
Okay, thank you, Pak Surya Negara, to given the opportunity for me to ask the question. Good morning, Mr. Rao, Mr. Ramesh Rao. Yeah. Okay.
Good evening.
So, actually, my question is, I just read the news a while ago that the silicon supply right now is in a shortage, right? And as we know that most of the Qualcomm technology is depending really on the silicon supply, as the resources is limited, and then the demand is increased, but the supply is limited, then it will impact to the price, of course. And then my question is, if there is any strategy that Qualcomm have prepared in the future, if there is something the same is happen with the supply of the raw material of this chip. Okay, I think that is my question.
Yeah, so regarding the supply shortage, I think our CEO recently answered this question. Yes, there was a lot of demand for our technologies and our products, and that is always a good thing. And so we did see the demand exceeding the supply that we had. And it continues to be the case for the foreseeable future. I think we will see it improving, but we will always see supply below the demand is what he predicted for at least the back half of this year. But things are improving, and the ways we have tried to mitigate this problem is to actually, we have several sources of fabs. We have several foundries that we work with. We multi-source several critical products, etc. So all of these above actions will hopefully get better and make the situation better going forward. Again, every silicon manufacturer is currently experiencing this, and each one has their own ways of handling the situation. But in our case, things seem to be improving, as our CEO has indicated in a recent press conference. So things are getting better based on what he said, and we hope to certainly see things improving soon.
Okay.
Okay. Thank you, Mr.
Yes, and we have Pak Naufan. Pak Naufan Rahaya, I saw that you raised hand.
Oh, yes. Thank you. That's a great presentation from Mr. Ramesh. And I want to ask about the hardware capability in current 5G. to implement distributed machine learning in user device, because when we apply like machine learning or computation in central cloud or edge cloud, we have a latency issue, especially in massive IoT system. And maybe we have privacy and security issues when we do the computation in the central cloud and edge cloud. So how's the current hardware capability to support distributed learning in user's device? Thank you.
Thank you. Okay, Mr. Ramesh.
Can you please summarize the question, please? I could not hear some of it.
How's the current hardware capability in current 5G development to support distributed learning in user's device? So we don't need to do the computation in the central cloud or edge cloud. Thank you.
Yeah. So in terms of the computation, three points at which computation can happen. Traditionally, very heavy processing has been done in the cloud, in the central cloud. And that is because of the extra processing power and the availability of power to actually make those processes happen exists on the central server. Data exists there, and that happens there, right? That was the traditional paradigm. The new paradigm is basically with the availability of heterogeneous architecture, low power consumption techniques, and with the prevalence of smaller models, etc., we can actually do that on the device itself. But the third paradigm that is evolving is basically this edge cloud, like I said in my talk, where some of this can happen on the edge cloud, and that can reduce the latencies. Instead of having the round trip cloud delay to the central cloud, you can actually do the processing with the edge cloud. That helps the data stay secure and private in the network, hopefully, and does not need to expose your data to the larger central cloud that is just makes it more insecure. So that is the paradigm that was being pushed at. And Qualcomm is a big believer that we will have this edge cloud with the 5G link that talks to the edge cloud and the central cloud available. It'll be a very viable concept that we will be pushing in the future.
Thank you, Mr. Ramesh. I think it becomes our last question and answer. And thank you so much, Mr. Ramesh. You have been with us for 2 hours and give us a very fruitful discussion and enrich our few general understanding about the future, especially again emphasizing much about the importance of 5G and the communication. Maybe you have a last final wrapping up this session, please, Mr. Ramesh.
Absolutely. First of all, thanks a lot for giving me this opportunity to address your engineering students. It's a pleasure doing it. Always have fun sharing my experience and understanding of certain technology matters with a larger group. I would also like to thank all of the interesting questions that were posted after this talk. Certainly gives me a lot of hope that people are absorbing this information and will do the right things to actually learn up and contribute to make their engineering careers definitely interesting and very rewarding to them. I also like to thank my colleagues Susanto and Nis, who were a part of this presentation. They helped me put the presentation material together and guided me. And a big thanks to the University of Indonesia team to set up this program and conduct it so efficiently. And very good discussions, and look forward to engaging with you folks at some point in the future again. Thank you.
Thank you so much, Mr. Ramesh. So we give a virtual applause to Mr. Ramesh.
Okay,
yeah?
thank you,
okay.
Mr.
Thank you so much,
Ramesh.
Mr. Ramesh. So, yeah, it is an honor for us to have this 2-hour discussion with you, with your very long experience and your capacity in this industry. So it built up our confidence that the future is with us, as long as we have the competence and mastering that future technology. I think that's the main point. We are living in this very uncertain world, future world, but with this technology, we are sure that we're going to survive it and mastering the future. Okay, thank you very much, Mr. Rames. Thank you very much, a student from Indonesia, University of Indonesia, and our colleague from UGM, ITS, and many other university, our partner, Qualcomm, Pak Susanto, Bu Nis, thank you very much. And another researcher, lecturer, Pak Aspial, thank you so much. And we meet again in the next webinar. Because University of Indonesia, especially the Master Program of Electrical Engineering, will have a regular webinar. Yeah, and just to inform you, please keep up with our information. As long as you put your WhatsApp number in the registration, we're going to send you the information. At the end of this September, we're going to have a webinar about the key technology that's going to be the future of 6G. Yeah, some of the candidate of the key technology for the next after 5G. And the next month, we're going to touch a bit about business on seeing how the stock on the telco company, yeah, stocks, yeah, we're going to see. And at the November, we're going to talk about terahertz communication, the future of the terahertz. And the December, we're going to talk about the economic spectrum of the communication, because some of the question, I think I saw that the question about regulation, the question about the regulatory, and touching about the issue of society, it will be further discussed on the next webinar. Thank you so much, and thank you, and I see you again. Good night for you guys in Jakarta.
Thank you.
Good morning, Mr. Rames.
Thank you. All of you.
I see you again. Yeah. Have a
Thank you.
nice day for you, Mr. Rames, today.
Thank you.
And Pak Santo, have a good sleep, and all of you have a good sleep for Indonesian people, and have a good day and good work for today, Mr. Rames. Thank you. Bye-bye. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Ada Greg di sana.
Happy holiday, Pak.
Greg, sorry, your question not I cannot read your question ya. Nggak apa-apa, nggak terjawab, nanti kita diskusi.
Siap.
Ya. Bapak-bapak, ibu-ibu, mohon maaf kalau questionnya ada beberapa yang tidak bisa kita detailkan, tetapi memang ada beberapa question yang sebenarnya itu diskusinya mungkin lebih nanti di webinar berikutnya. Contohnya misalnya kayak tadi bagaimana 5G akan menggantikan masalah pekerjaan ya, ada yang nanya kan, apakah akan terganti, pekerjaan akan tergantikan, itu nanti akan lebih ke webinar berikutnya yang lebih touching ke society. Akhir November kita akan discuss menarik sekali, yaitu the future 6G. Ya, 6G itu nanti isunya. Jadi karena 6G ini belum, 5G aja baru akan mulai, tapi 6G orang sudah membicarakan kandidat-kandidat. Salah satunya yaitu maaf, apa namanya itu? AI, based on AI ya, distributed machine learning. Maaf, distributed, salah satu key-nya adalah pasti menggunakan machine learning, tetapi distributed machine learning. Nah, itu jadi bagi Bapak Ibu yang special, yang technical side, must come on the next webinar. Dan untuk yang akan lebih ke managerial side, itu Oktober kita akan, ini bidangnya Mas Gregorius Ivan ini. Kita akan membahas mengenai cara membaca saham industri telco.
Saham dulu.
Orang manajemen telco.
Ngomong saham Ngeli.
Saham untuk manajemen telco. Karena ini teman-teman dari manajemen telkom dan manajemen yang manajemen teknologi pasti akan sangat relate dengan ini. Bulan November kita akan bahas mengenai terahertz, dan bulan Desember kita akan bahas mengenai bagaimana memvaluasi spektrum, economic spektrum. Saya ada orang bertanya berapa nilai spektrum 5G, berapa harganya, berapa juta dolar. Nah, itu ada cara memvaluasinya. Bukan saya yang mengisi, tapi orang ekonomi. So, stay tune ya. Oke?
Terima kasih Pak Surya.
Terima kasih semuanya Bapak-bapak.
Terima kasih banyak Pak Surya. Terima
Sampai
kasih.
jumpa lagi. Terima kasih. Selamat malam. Assalamualaikum. Saya N ya.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Pak.
Terima kasih Pak.
Stay healthy.